Hey everyone, we are continuing with question 5 of the 2020 Math Paper 1. And yeah, question 5 says that we're given the graph of f of x equals to 3 to the power of minus x. It's sketched below or to the side. I just moved it over there. And it says A is the y-intercept of f. Okay, that's that point over there. And then B is the point of intersection of f and the line y equals to 9. So that's B over there, that's intersecting with x or y equal to 9. Okay, first question, it says write down the coordinates of A. Okay, so we can see that A is our y-intercept that was given to us. And to get to the y-intercept, we make x equal to 0. So if x equals to 0, we obviously know that on the origin that x is equal to 0 there, so that's our x coordinate already. So we can say f of 0 equals to 3 to the minus 0, and of course minus 0 is the same as 0, and anything to the power of 0 is a 1. So therefore our coordinates for point A is 0 and 1. Easy one mark. Okay, question 5.2. Determine the coordinates of B. Okay, so we can see that B is on y equals to 9. So we already know that our y coordinate is 9. And to get to our x coordinate, we can substitute it in our function in the y spot, so it becomes 9 equal to 3 to the minus x, and now we just solve for x. To do that, we need to make the bases the same, so 9 is 3 squared, which equals to 3 to the minus x. Since bases are the same, our exponents are equal, so therefore 2 equals to minus x, divide both sides by minus 1, so x is equal to minus 2, and yep, that makes sense because it's on the side, so we know it's negative, and negative 2 is exactly what we need. Therefore B's coordinates are minus 2 and 9. Coolio. Okay, 5.3, write down the domain of the inverse of f. So the domain is all possible x values where the graph exists, and so we can determine our inverse of f. To determine the inverse of f, we simply start by exchanging our y and x values and then solving for y. So it will then be x equals to 3 to the minus y. Okay, and then to solve for y from here, we're going to introduce logs on both sides. So that becomes a log of x equals to the log 3. Can then move our exponent forward, so it becomes log of x equals to minus y log 3. We're still continuing to solve for y, so we can just divide it by everything else, so it becomes log of x divided by log of 3, well, negative. And this log of 3 is just a number, so it's basically a coefficient, and all we're left with is negative log of x, and the graph for log of x, it looks like this, coming down here, going through 1, and it's a little closer, but I think that's the idea. And it goes through 1 here, I'll let you guess why why it goes through 1. If you know why, then kudos to you. But the basic idea from this graph, we know that this graph exists everywhere where x is greater than 0. So from this point here onwards, and that's your answer. So the domain of the inverse of f is where x is greater than 0. Cool. 5.4, it says describe the translation of f to h of x, which is equal to 27 divided by 3x. So f of x is equal to 3 to the minus x, and h of x is 27 over 3 to the x. So this divide makes us, so we know we can actually rewrite h of x, so we can simplify it a little. We can make this 27 multiplied by 3 the minus x, and of course 27 we can rewrite as 3 cubed multiplied by 3 minus x, and if we are multiplying two bases, we add exponents. This becomes 3 to the 3 minus x, and to make things a little easier for us, we can take a negative out of there, so this becomes 3 the minus x minus 3. So how does this graph look? Okay, so it looks very similar, because it is similar. It's just we are shifting it 3 units to the right. So how do we know it's to the right? We can see that our y-intercept is now going to be, if we make this 0, it's going to be 3 to the 3, which is 27, which will be like way up here, and it will still look the same. It will still have the same shape, so it will come down like this and go all the way there. And to get to 1, where our y value is 1, all the way down over here, this will be at x equal to 3, so it'll be about here. Okay, you know, it's not thrown, but because if we substitute 3 into here, this becomes 3 minus 3, which is 0, so it gives us that point, where this point before was on 0, on x equal to 0, but now you can see it's actually on x equal to 3. So our so the movement, or the translation from f to h, was 3 units to the right. So it's the exact same graph. So if I had to throw it here, okay, I can't throw it here because it's 9 is too high, but it would be like at 27, and then it would come all the way down, and then this point here would be at 3. So this whole graph was shifted to the right by 3 units. Okay, then final question, determine the values of x for which h of x is less than 1. Okay, so this is okay, I guess I can use this so I am drawing here. Okay, so less than 1 would be all, so here's our 1, remember, so it would be all these values below this line, and you can actually see, because of the previous question, that is we know it's going to be at this point 3, because it actually helped us in this place. So it's going to be where x is, and it's all, you can see all the it exists on the right hand side, so it's greater than, so it's greater than 3. So that is a good way to explain it. But if you're just gonna write this, I'm pretty sure they'll just give you like 1 mark, because they'll probably think you cheated if you looked at someone else. So a more like systematic way of writing it, we can go back to our function of h of x. So it'll be 27 divided by 3 to the x So we want this to be less than 1, and now we can just solve this as usual. So it becomes 27 is less than 3 to the x, because we multiplied, and then we can do the same base thing. So it becomes 3 cubed is less than x is less than 3 to the x, and we can see our bases are the same, so it becomes 3 is less than x, which is of course the same thing as x is greater than 3, which is kind of what we were able to conclude from our graph. And that's it. I think this is more likely to give you 3 marks, so they would mark you something like identifying this, which is you just replace the h of x with what h of x is, and then a mark for your method and a mark for your answer. There we go. This should be a quick shorter video. I hope it helped, and I'm out.